Alright, what's up everybody? So today we're going to be doing we're going to be finding the area between these two curves. So let's recall that we have a hyperbolic function which is equal to the exponential function divided. Let's just keep that in mind. Okay, so let's just jump straight into it. So the first thing we want to do is find the intersection points. So to find the intersection points, we can set these two functions equal to each other. So we have sine of hx equals e to the negative x. So again, if we go back to our definition, sine of x, sine of h, or sinh, as most people call it, is equal to the exponential function, which is f e to the x minus e to the negative x, divided by 2 equals e to the negative x. Right? If we multiply both sides by 2, we're left with e to the x minus e to the negative x equals 2e to the negative x. Now, let's pretend that we divide the exponential function. Therefore, we would have e to the x minus e to the negative x equals 2, all divided by e to the negative x. Now you might ask, what do we do now? Well, what do we do now? What could we do now? You know, it's a good question. It's a good question. We know that property that, so you have 2 to the negative 1, it's equal to 1 over 2 to the 1. You know that property? Well, that property is the same thing. It works backwards as having 2 to the negative 1. It would be 2 to the 1. So we could do this with here. With this, so this would be e to the x minus e to the negative x. And multiply this by e to the x equals 2. And then we would just distribute e to the x times e to the x, same base, add the exponents, so we have e to the 2x minus e to the x times e to the negative x, negative 1 plus 1, 0, e to the 0 is 1, equals 2. So taking, well, we have e to the 2x equals 2 plus 1, which is 3. So taking the ln on both sides, we have 2x equals ln of 3. Now recall that the logarithmic function of e raised to some exponent equals b, because there's an implied e here. Just a little refresher. Should have learned that in 5th grade. Anyways, we have x equals 1/2. If we divide both sides by 2, we have 1/2 ln of 3. And from here, it's really just algebra, because you can bring the 1/2 up as a power, and then you would just have ln square root of 3. I prefer that, but however you prefer, really. There's no wrong or right way to do this. Now that we have the intersection point, x is equal to ln square root of 3, we can go ahead and graph it. let me graph this real quick. Oh, that looks like a nice graph. We have 1, 2, 3. We have 1, 2, 3. We have 1, 2, 3. We have 2, 3. Okay. Okay. So we know that e to the negative x goes through 1. And that is the graph of y to e to the negative x. And the graph of sine of h, I believe, hold on, I think it's like that, and it goes through, I think it's like that. Just to get like a rough idea, you know, this is sine of hx. So we basically are going to be integrating this area right here. Remember, this is 0, 1, and 2. So we're going to be integrating that area from 0 to 2, right? So let's go ahead and find it. We have the area will be the integral from 0 to that intersection point. Recall this is the intersection point. It's not 1. You know, that graph is not to scale, but we know that these two graphs meet at ln square root of 3. Now we're integrating with respect to x, so we're going to do the top curve minus the bottom curve. So we're going to do e to the negative x minus sinh of x. So we're going to do e to the negative x minus dx, differentiate with respect to x. I'm sorry, anti-differentiate, plus the integral from ln square root of 3 to 2. And that's going to be the top curve minus the bottom curve. So it's going to be sine minus e to the negative x with respect to x. Okay. So taking this, we will have a negative e to the negative x minus take the, it'll just be cosine of hx, because the derivative of cosine is sine. We'll call it cosh in this case, cosh, however you want to call it. 0 evaluated. These are the integrals evaluated at 0 and the natural logarithm, plus cosh of x minus the negative e to the negative e to the x evaluated at ln square root of 3 and 2. Now it's pretty simple algebra from now on. What do you think? You know, I think that definitely it's interesting when you get to higher level classes. The math just keeps getting, sometimes the concepts may seem to get easier, but the algebra, it's really just the algebra that gets you, it's just, it's different, Anyways, let's evaluate. We have negative e to the negative ln square root of 3 minus plus e to the negative 0 minus cos of ln square root of 3 minus cos of 0. That's 1. And that'll be plus, whoops, sorry for the horrible handwriting. Should have been a doctor, they said. Plus cos of 2 minus cos of ln square root of 3 plus e to the negative 2 minus e to the negative ln square root of 3. Now, how in the world will we solve this? Well, really you gotta practice your fundamentals. It's your fundamentals. I cannot stress it enough. I get it all the time. Students come to me and they tell me that, Professor Hustlenomics, I really can't figure it out, and most of the time it's really just the properties. It's really just your properties that you learned in the 5th grade. Well, not the 5th grade, but in pre-algebra and pre-calculus. Anyways, that property that's e raised to the natural logarithm. Remember that the natural logarithm has an implied e right there, but we just don't write it. We just know it's there. Therefore, if that's raised to another e, then it's just going to equal what? Well, remember that this is raised to a negative exponent. This is just going to be 1 over e to the ln square root of 3 plus 1 minus, well, that doesn't change. That is minus 1 plus cos of 2 minus cos of ln square root of 3 plus 1 over e squared, again, minus 1 over square root of 3. See, that's where just those little tiny small properties that you just don't remember sometimes. It's hard for you to remember. I don't know, it just doesn't click, but that's what makes the difference, baby. Practice, practice, practice. That is what makes the difference. I'm not sure why I wrote a bracket. Okay, so what do we have? You want to analyze. We have a negative 1 over square root of 3, and then we have another negative. So we can do 1 minus 1. So we can do this. We can do so what is negative 1 minus 1 over square root of 3? Same denominator, it's minus 2 square root of 3 minus cosine of ln square root of 3. That'd be plus 1 plus 1 plus 2 plus cos of 2 minus cos of ln square root of 3 plus 1 over e squared. Okay, now what else? What else can we do? Well, ladies and gentlemen, it looks like we're about done here, because that is everything that we can do. You know, we really can't do anything much. I'm looking, and we can't do anything much. That is it. That is our answer. Oh, we could do is negative cosh of ln of square root of 3 minus cosh of ln of square root of 3. So we would have a minus 1 cosh of ln square root of 3. Right, so we did that. And that, ladies and gentlemen, is our answer. Y'all have a howdy day.